Hi there! In this presentation, I'll be sharing how I investigated the potential impact of congressional stock trades on market prices using advanced data science techniques, putting machine learning, large language models, and vector databases to work. Let's dive right in. Congressional stock trades are disclosed under the Stock Act to foster transparency. However, do these disclosures influence stock prices? Are there congressional stock traders benefiting from policy investigation? Can I get rich by copying trades? The goal here is to perform a comprehensive post-transaction analysis covering the years 2022 to 2025, aiming to statistically determine whether congressional stock transactions influence market prices. Specifically, we seek to explore if large buy transactions by Congress members lead to a positive impact on associated stock prices, and if large sell transactions aid in minimizing losses during downward market trends. This analysis will utilize predictive modeling to compare actual stock price movements against expected trends based on similar stocks, helping us identify any significant deviations that could indicate the effects of congressional trading actions. The approach we followed was to join Congress stock transactions with the daily closing stock prices, develop a criteria to aggregate stock transactions until we reached a threshold, identify similar stocks based on metadata of tickers, and predict stock prices based on this control group, and determine if there is causality. And if there is causality, use AI agents to pull up associated news and see if there are any legislative news that correlate to these events. Now, let's dive deeper. We first extract Congress trade reports and closing prices for the entire stock market from Yahoo Finance. Then, we head over to data filtering, where we start by grouping ticker, transaction type, sum of transaction, min of date. We want to aggregate to a threshold of $300,000, after which the algorithm resets. Here, what we want to do is identify tickers with higher portion of trades on buy or sell. We also want to identify intervention date, which is the date from which the stock was invested upon. Next, to build a control group, we filter similar stocks for a ticker using the metadata of stocks and by using a vector database, FAISS. A hybrid embedding approach is used to encode the metadata information such as description, market cap, sector, and industry information, and the weights are manually adjusted. Similar stocks are identified using cosine similarity. Here, what we hope to do is, given a ticker name like Apple, we get the 5 closest performing tickers as a response, as you can see over here. Now, to detect causality, we use Bayesian structural time series, or BSTS, where we would forecast the price of a particular stock by the performance of similar stocks or our control group. The model will detect causality if there is a significant deviation in distribution that is occurring in the post-intervention period between the control group trend and the actual ticker. Here, the outcome that we want to define is if causality is detected or not for that particular stock ticker. If there is a causality, we head over to our AI agent for investigation. We start with a query agent built using OpenAI, where we generate queries to filter news that could relate to government or policy involvement associated with the stock. This way, relevant questions are asked for the ticker instead of the same question for all tickers. Then, we go to a search and retrieval agent who will retrieve all the responses and compile answers for the questions being asked by the query agent. This we built using Perplexity. Finally, we head over to the editor agent, which we built using OpenAI, and we pass all the responses and queries so that it can validate the filtered responses to check for relevancy and summarize the results. With this outcome defined, now we can clearly see if there was a corresponding news event that occurred in addition or parallel to this causal event. Here we have an example with NVIDIA, which was a stock that we identified in the app. To make these insights accessible and continually evolving, we've built an interactive app. It consolidates our findings and updates as new data becomes available. You can explore specific stocks, examine trade clusters, and see how the model tracks market changes over time. We also have a paper that I've linked here and a feedback form that will be incredibly valuable for improving the user experience and refining our analytics pipeline.